All right, I think I'm live here. Time to open QuickTime. Apple Pencil I've charged. Good. New movie recording. Get my iPad there. Good. Okay, not the problem sets, but the exams. Exam 1 PDF. I'll get the chat to be ready to grade it. I think I've downloaded this before, but might as well download it again. Download file. Oh god, this is way too much. Oh boy. Okay. You know what I should do is I should open this. Does that work? Oh, I got a periodic table. Sick. All right. I'm just getting this exam all set up right now. I'm going to take the first exam in this attempt to learn organic chemistry from scratch using nothing but ChatGPT and Grok. I used a little bit of Claude, a little bit of Gemini, but it doesn't really help that much playing the AI ping pong like I thought it would. Kind of just stick with one. Keep it simple. It'd be nice if I had diagrams. It'd be nice if I had videos. It'd be nice if I had a textbook. I'm really looking forward to reading textbooks like Organic Chemistry as a second language, because this is like a second language. There's a lot of terminology. First linear algebra and then OChem. I don't know why I picked the classes that are so terminology rich to use as these tests to see how far AI can take us, but man, not easy. So, oh god. I didn't memorize the pKa's. I forgot I was supposed to do that. I can already see this is going to be tough, but let's go right here. First, I want to get the one with the solutions. I'm not going to look, but I'm going to download the file. Okay. Grade my answers to the MIT final. Okay. Make this smaller. Here, I got all this now. This will be my first test. I'm going to just go up in the corner. Zoom in a bit, why not? All right. So, no, oh, this is the key. I don't want to look at that. 14 questions, yikes. I've only got about 40 or so minutes, so I'm going to skip ones that are not working out for me. Hopefully my audio and stuff's working. Cool, my microphone's on. All right, this is all looking positive. And by that I mean I don't know what the first answer is, but whatever. Okay, so I'm just going to write 1. The pKa of an sp, hybridized carbon atom. I mean, honestly, I have no idea, but I know what pKa is. It's about the acid dissociation. It's weird to think of just a single carbon atom as having a pKa. But let's say that it's, I don't know, C. Number 2, circled letter. We're just going through this. I'm going to have to review the answers because this should be a learning experience. Day 6, nice. How many hours has it been altogether so far? A little less than 5. Less than 1 hour per day. Yeah, I'm 1 hour per day max. I usually split it up into 2 streams. Sometimes it's like 40, 20. Sometimes I only get 1 stream in. But I stream for less than 1 hour per day. It's the only time I'm reviewing besides little bits and pieces of spaced repetition practice that I've done outside using my app that I built, Snapwise. So 5 hours into learning organic chemistry from scratch with AI. A lot of questions, but I don't have... yeah, it's... been a journey so far. So circle the letter of the molecule with the lowest barrier to rotation, or ring flip. Okay, so 2A, molecule with the lowest barrier to rotation. So me eat peanut butter. I assume one of them cyclohexane, so I could just go and split the difference and say cyclohexane for both, just because it's different than the rest. I've done more studying than most of the people in my class. Yeah, people don't study much these days. That's the crazy thing about this education these days, is how little people study on median, on average. So me eat peanut butter, methane, ethane, propane, butane. This is dealt with single bond. So the highest barrier to rotation, I assume, would be I'm just going to guess that the highest barrier to rotation, I hope I didn't mix this up, is ethane. Me eat peanut butter because it's just double bonds. Or just 2 carbons. And then cyclohexane. Okay, I don't know. Rank the following substituents in order of priority. Okay, priority. 1 is highest priority. So the order would be... I forget how priority works. So let's see. Ooh, it's warm in the almost summer in LA, wearing a suit with a tie. I probably should not be drinking a hot green tea, but here we are. And I do need a little caffeine boost. So CH2, Br, CH2, NH2. Whew, okay, I'm going to guess that the order is, the last one is 1, I'm going to say, because bromine, halogen, that's strong electronegativity. And then this double bond, I'm going to go 4, 4, 2, 3, 1. Total guesses. If a chiral molecule has an absolute configuration of R, which direction does it rotate the plane of polarized light? Chiral means that it's not superimposable, the mirror image. I'm gonna just guess A for 4. I'm gonna just grade these first 4 right now. So I screenshot this. By the way, I can check off these on my little focus notes. And I'll add, last thing is review answers. Okay. And I didn't screenshot it. I'll just look at the answers for those first 4. Screw it. Not going to look at more than that. I don't want to cheat. Okay, well, I was wrong on the first one. 0. Circle the letter of the molecule with the lowest. Yo, I got that right. Sick. 2 of 3. 4, 2, 3, 1. Holy crap! My instincts are insane. It can't be determined. I feel like that's always a trap, so I got that wrong. So I got 4 out of 6 here. First page. Second page, enter the pKa value for each acid in the boxes below. Indicate whether the reactants, I'm going to just go over here now. Indicate whether the reactants or products will be favored at equilibrium by circling the appropriate set of equilibrium arrows. God, I don't know any of the pKa values. I forgot I was supposed to memorize these. God. I need my fan. I'm going to be way too hot. Okay. Oh boy. Turning up the heat in here. Ooh, oh, it's nice having a little breeze. This is the part that's going to be bad. I can already tell you that. So I know it goes to the side with the weaker acid. And is the weaker acid going to be this cyclohexane thing with hydroxide? And a negative HO? That's the proton acceptor. Yeah, I assume it's to the left. I didn't realize this was going to be a test that I had to sort of mark up myself. Like I should have printed this and put it onto this, but I don't have the technology. I don't have the time. So 5 is left, and on this side it's going to be 25, and on this side it's going to be... Oh, I think water is something that I should know, actually. Is that 35? I don't know. Making this 45. Whoops. Okay, this next one. Okay, so we have this H3C. I feel like this is a lower one. 6, I'm going to say. I'm totally guessing on these. But let's say that it goes to the right on this one. And that it's seven and 20. And then number 6, I don't know if GPT is going to be able to actually transcribe this. Let's see. 6 points, so that's already not good. Provide structures in the boxes to complete the following acid-base proton transfer reactions. For each set of reactions, draw in all lone pairs of electrons and show the electron movement by using curved arrows. Indicate whether the reactants or products will be favored to equilibrium. Oh boy. Okay, so for this one, I have H. I haven't drawn any diagrams in these 5 days of learning OChem. So big mistake, just because, again, this is an obvious, whoops, I'm copying down the wrong thing already. This is a big limitation of just learning it only using large language models. H, H3, C, N, H. Gonna have to try to figure out how this works. From the one above. So let's see. We have a positive charge around there. This is a positive and neutral. So one of these is going to be positive, a product, and basically an H is transferred. So I assume that the H goes to this one, and that one becomes H plus. So it's going to be I'm going to say this arrow. How many more pages of this crap are there? Oh no. Metenkephalin. This is so stupid to do it like this. Okay, I need somebody to annotate this. I'm just gonna see if I can open this. Download. No, I don't want to open it there because I don't think I can annotate it there. If I click it here, it should open. Yeah. All right. So I'm going to finish drawing these things. So I think the way it'll look is those are the reactants. Then the products are going to be so it goes to a single bond of the nitrogen. N H H3C H plus H. I think that's right. Oh wow, these are kind of the same thing. Which way is favored though? I know 4.0 is just going to glaze me if I try to have it graded again. That's what it always does. So this looks like a, see, how do I know what the other thing is? It's H3C. I'm just going to guess that it's like H2O. And then it goes to, no, say that it's plus H3C. So C, H, H, H. I'm just drawing this, then I'll reference it. And I'm going to say this is right, this is left. Because I just decided that. And then it'll be HF3, H3F in the other. All right, what did I say for this? 45 and 35 to the right. So that's 0 points basically. And this one was to the left, yep, the other way. And I said 7 and 20, yeah, both wrong. That's 0 points. So now I'm, just to keep track, 4 out of 12. Provide structures in the boxes. Okay. Yeah, this is right. I got this one right. I said left and right. Yeah, so this is good. And then this other one, I would draw the N. I said it was the same thing as this other one, which is true, except I didn't draw the arrows. Oh, I needed to draw the arrows in the lone pairs. Why does this one go like this? I need to have it explain this to me, but let's see. H to O. Have you tried using Google Gemini 2.5 Pro on AI Studio with the 1 million context? I think once, but I didn't get into it enough. For whatever reason, Gemini just is always slightly off. It's, I don't know. Maybe I just need to prompt it better. But I haven't been that impressed. It seems pretty mid compared to ChatGPT. And even Grok I like better in a lot of ways. So let's see here. Did I do this one right? Well, I got I got that it was right that it was that direction, but I got it wrong that it was all this. F3C versus H3C. The H. I can give myself an honest 6 out of 10 on this one. So that means that I'm now 10 out of 22. Oh, I have to rank these now. I'm just going to be like guessing this out loud and seeing how I do. It's too hard to do all this. So rank these in terms of acidity. HCl is 1.
Oh my god, awesome.
All right, 1 is there. Here, I'm going to move this. I can just unpin it. One. And let's see. H with P, H with C, H with C. One is most acidic. I'm guessing this one with sulfur. And then I'm guessing this is 3. Sorry for all the noises in the background, guys. The house is crazy. Then this is 4. I'm just going the ones with sulfur for some reason. Why? I'm not 100% sure. Hydrogen bond, that's probably pretty strong. 5. Oh, phosphorus should have gone up there. 6. There's no way I'm getting this right. This is just guessing. I'm basically guessing on this test. It's not great. So clearly I have a lot to learn, but I'm going to try to review this shortly. Which is going to be worse between these two? These are just almost like resonance to each other. Oh, CH3 and stuff. So this one's going to be lower. I'll say this is 10. And this is 9. 8. All right. I was right about 1. I was right about 2. I was not right. Oh, I missed this one. 3 and 4. I mixed up. Oh, this was also 1. Oh, it's in each row. So 1, 2, 3, 4, 5 is what I did. 4 to 5, and then this one was 1, 2, 3, 4, 5. Okay, so I'm gonna give myself the solid 5 out of 10 here. I get 4 to 5. Yeah, 5 out of 10 is fair. I'll give it 6 out of 10. 16 out of 32. And I still have a lot of tests left, don't I? Met and enkephalin, an endorphin. Okay, so I need to circle all the functional groups. Well, I know that there are a lot here. Wow. This is a functional group. 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 Is this a functional group? I'm not sure. I think whenever there's an O like that, it is. Am I crazy? All this O and H, those probably aren't functional groups.
So what time do you think you guys will come to Violetta's birthday?
And this is ketone. This is.
It's from 3 to 6.
Each of those is a functional group. Shoot. And that is carboxylic acid. Okay. Arene. I should have circled those. Phenol. Amine. I'm going to give myself 2 on that. 18 out of 48. So let's go next one. Name the following molecules. Oh, shoot. I'm not looking at the answer. Sorry. Name the following molecules. I have no idea how to name this. Oh, actually, maybe I can. 1, 2, 3. Wait, I need to do the shortest distance. 1, 2, 3, 4, 5, 6, 7. Is that right? Wait. One, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Huh. 1, 2, 3, 4, 5, 6, 7, 8. It's actually 8. Okay. So this is oct. And how do I name the rest of it? This is brome. And then 1, 2, 3, 4, 5, 6, 7. And then there's another group. So bromyl. I'm guessing this is bromyl septane. Septarine, I don't know. Octane. Okay, so oh boy. This is octane. I got that there's 8, yep. And then it goes 4 isopropyl. 3, 5, 6. So it's 4 isopropyl. Whoa, that's a crazy name. 4 isopropyl. These are the different functional groups, I guess, off of it. 3, 5, 6 trimethyl octane. Okay, I'm going to spend a whole day reviewing this test, just putting each of these into 4O and asking it to explain. 4 isopropyl, 3, 5, 6 trimethyl octane. I got the octane part right. Trimethyl, how do I see that? 3, 5, 6. Yeah, 3, this is a methyl. 5 is a methyl. 6 is a methyl. And 4 is the propyl. So 4 isopropyl, 3, 5, 6. So that's where you denote which carbon it is, C3. Okay, that makes sense. I haven't done naming stuff nearly that intense before, though. 3 methyl groups, so tri. Yeah, thank you. I own dog. I don't know how to pronounce that, but on Twitch, someone just explained it, which is very helpful. So 3 of the methyl groups. I just didn't know how to recognize methyl groups from just a skeleton diagram like this. I think that's what's called a skeleton diagram. And this one, oh boy, trans 1, bromo 1, 2, 3, 4. Oh, that's all I do? Bromo, trans 1, bromo. I don't know why it's trans, maybe because of this thing. Trans 1, bromo 4. What does that say? Tert, butyl, cycloheptane. It's a cyclo. I didn't get into the cycloalkynes and all that. Cycloalkanes, I should say. Cycloheptane, because there's 7. I'm gonna give myself max 2 on that. So now I'm at 18 or 48. I'm gonna say I'm now 20 out of 52. We're flunking this, guys. I'll tell you that. 16 points. This is big. Draw the 4 major resonance contributors for the molecule shown in the box. Partially completed structures are provided as a time saver. Do not generate any additional charges. Draw in all lone pairs of electrons. And use arrows to show the movement of electrons within the structure. Place a check mark in the small box of the 3 structures that contribute the most to the resonance hybrid. Then circle all of the nucleophilic atoms. That means that they want protons. Okay, so that means that they're, I think it's going to be this and this.
Well, the first thing you do is saute the garlic.
And between these two, I think it's going to be this, yeah. You know about resonance structures and how to draw them already? Yeah, I don't really know about resonance structures. I know what they are. I understand that they are multiple orientations, sort of. I'm probably going to goof this a little bit, of the same molecule that contribute to a more stable hybrid. I don't have much of a visual for that or how to draw resonance structures. I know there's some curved arrows involved and all that, but honestly, it's kind of beyond me. So here there's a bunch of these different diagrams. 4 major resonance contributors. I don't know where the lone pairs are. I don't know where just about any of this is. Circle all of the nucleophilic. Okay, place a check mark in the small box of the 3 structures that contribute the most to the resonance hybrid. And I'm going to just guess this one, but then I don't know how to determine what contributes to a resonance hybrid. What determines what contributes more than another thing. Circle the structures that represent a conformation of 2, 2. Let's see. Place a check mark in the small boxes. Okay, let's see. Oh. Check mark in the small boxes the 3 structures that contribute the most to the resonance hybrid. Circle all the nucleo. God, this is impossible. I have no idea here. I might as well draw something. So the major resonance. Yeah, I don't know how this works. I'm gonna have to just look at this. So this is a fail. Let's see if I checked. And these are all identical, so I haven't really done anything. That was a check. That's good. That's 1 point. Oh, lone pairs in the oxygen was easy. I could have done that. And I go here and here. Yeah, I don't understand the resonance structures. I'm going to have to thoroughly review this. I got the O's and I got the N's. That's 3. So 3 points. I could have gotten these on the nitrogen. That's not hard. Wow. Yeah, that was rough. So if I'm being generous, I get myself 3 points for these circles, 1 point for this check mark. It's 4 out of 16. So that's 24 out of 68. It's getting worse as we go. All right. Circle the structures. Okay, we got some Newman projections now. Circle the structures that represent a conformation of 2,2-dimethylbutane. Dimethylbutane. at the 2 and 2. So complete each of the Newman projections below to show the most stable and least stable conformations of 2,2-methylbutane sighting along the C2-C3 bond. All right, so, oh boy. So I see there's methane, methane, ethane. I'm gonna guess this one. And this one. No. And this one. Dimethyl CCCC. I don't think this is one of the things to circle. I think it's just this. I'm hoping it's the top two. Okay, so to complete this Newman projection, I need to go. H and H. H and an ethane.
Which is normal. This is the time when you get.
Let's see here. You know about yeah, people are asking me things in the chat I just haven't learned properly. Use the above Newman projections to calculate the barrier to rotation of 2,2-methylbutane sighting along the C2-C3 bond. Use the above Newman projections to calculate the barrier to rotation. 3? I have no idea what the answer is. I might as well just draw something here. It's going to be most stable is, this is the most stable, this is the least stable, and I'm just going to put H, ethane, ethane, methane, methane, or something like that. Okay, this one just gets crossed off. Whoops. So I got one of those. Nothing like this is what I was suggesting. The barrier to, yeah, I don't know if they give you these values. This is all the gauche and eclipsing stuff that I don't get. I'm gonna give myself 2 out of 12 on that one. 26 out of 80. These MIT exams are brutal. How many more are there? 12, 13, 14. Extra credit. Wow. MIT with the extra credit. Draw in the substituents on the ring flipped conformers of each molecule, A and B, to predict which molecule is lower in energy. Show the Newman projection for each ring flipped conformer sighting along the C5, C6, and C3, C2 bonds. Okay. Draw in the substituents on the ring flipped conformers of each molecule. Yeah, I didn't learn chair conformation. Which structure is lower in energy? Yikes. Lower in energy? I'm just going to say A. I can't tell you why. Because something about the plane of the CL. I mean, let's see what this says. So they drew this CH3 and CL, and then the H's around. CH3, CL, CH3s. Yeah, I don't understand Newman projections at all. It was way better linear algebra than organic chemistry for these things, actual problem solving. H3C, CL, CH3. Circle a chair conformation that is lower in energy for each molecule. It was both the lower ones. A was right. A has fewer 1,3 diaxal interactions on its whatever. Okay, I'm giving myself 2 out of 12 on that. 28 out of 92.
But the egg whites, when you stuff
This
them
ain't
with
looking good for
the
me.
filling,
Might have to drop out of pre-med at this rate.
but when you stuff them, they're
Label each molecule as chiral or, oh, whoops. Chiral or achiral. Or achiral slash meso. Designate each chirality center as R or S. Okay, this one actually seems achiral. This one also seems... This one's meso, probably. This one's, I'm going to go A. This is chiral. For each chirality center, I don't understand R and S right or left. But I guess it's something like R, S. I don't know. Let's see. ACM. I was right about that. So then each chirality center, though, S, S, S front, R back. So I'm giving myself 0 out of 4 on those. But the rest, let's give myself generously 6 out of 9. They're 34 over 101. All right, indicate the relationship between the two molecules as enantiomers, stereomers. Yeah, this is the perfect book for a lot of this. Year 1 is a small one. It's called Organic Chemistry as a Second Language. Yeah, someone actually mentioned that to me. I should literally just read that book. Be much better than all this struggle. Maybe I should just order it now. Is it on LibGen? I shouldn't show myself on YouTube going on LibGen. Not on a live stream. All right, indicate what's LibGen. I don't know. Never heard of it. Don't check it out. Indicate the relationship between the two molecules as enantiomers. Shoot, why do I keep looking at the answers? Enantiomers, diastereomers, or the same molecule. So let's see if I can find out which ones are the same molecule. CH2OH is next to CH3 and OH here. OH.
Are you putting them in cold water afterwards? You put them in cold water after or leave them out?
I'm going to say this is E. This is D, and this is S. I mean, I don't know. Off to bed. Yo, thanks, IN. Bless, man. Thanks for tuning in. I got all those wrong. Enantiomers for these ones. Enantiomers for these ones. Diastereomers for this one. None of them are the same molecule. Yikes. So, I can't really give myself any points for that. So that's 34 out of 110. Yikes. All right, last one. Oops, I'm not looking here. Maybe I won't be able to do it anyways. One of the steps in fat biosynthesis is the hydration of crotonate to yield 3-hydroxybutyrate. The reaction occurs by addition of OH to the C face at C3, followed by protonation at C2, also from the C face. Label the top face of each alkene carbon atom as Re or C. I don't know what the heck that is. It's some RS stuff that I didn't really learn. Label the top face of each alkene carbon atom as Re or C. Show the stereochemistry of the product and label C3 as R or S. So I don't know how to show the stereochemistry of the product. Label C3 as either R or S. C. Label the top face of each alkene carbon. I got no freaking clue for this. Ray, C, 3, 2. H3C, SOH. Yeah, that's 0. All right, 34 out of 110. See how the grading works. And let's see what the curve is. The curve usually test like this for OChem at MIT.
Steve Martin?
Really?
Yeah.
He plays the banjo in the
Yeah.
bands that we're seeing?
No.
Oh, in general.
Yeah, we saw him in a one-man show once, so maybe it was a two-man show with that other.
Average is 50 to 65.
That's fun.
And he played the banjo a lot on the show. He seemed like a reasonably good banjo.
If I got a 34 out of 110, what would that curve to?
And
Clearly, I don't know it.
you don't know any, well, what you've been hearing.
Yeah, no, I know. I'm just saying, like, what's your connection then? How long have you
The stream's gonna wrap up soon, guys. By the way, 40 minutes. That's about how long I said I had. We gotta go.
Put it this way, he probably won't be going much longer, but I think he's 90
Well,
something.
you must be doing okay.
Might just be enough to pass.
On till 10 p.m.
Waylon, yeah, but I know he's much longer.
Yikes. All right.
Waylon Jennings.
Now, I'm going to do another stream later, guys, where I go over these answers. I'm going to have to basically paste each solution into ChatGPT, ask for detailed explanations. And I think GPT is the way to go. Its image recognition seems to be way better than the others. So, review answers is in the next one. Thanks, guys, for tuning in, and I'll catch you next time. I kind of passed.